let's look at how we can solve triangles using the trig ratios that we learned. Okay, so our goals for this lesson is first to solve for a missing side in a triangle, and we'll do a couple examples there. Then we're going to solve for a missing angle in a triangle, and then we're going to look at a special relationship that happens when you're using sine and cosine that lets us solve in another way. Okay, and we'll do 5 short problems there. Okay. All right, so first looking at a missing length, a missing side length in a triangle. So we have triangle ABC here, and we want to find AC, which is marked with a question mark. Notice we have very minimal information, but that's the beauty of trig, is you don't need very much, okay? We have that it's a 90-degree, that it's a right triangle. We have an angle measure, and we have a side length, all right? And we have an unknown. There's something we want to solve for. So there's 3 main steps we can use. First, we need to determine which trig ratio to use. And to do that, we look at the information that we have and the information that we want to know. Okay, so I know it's a right triangle, has to be a right triangle to be able to use our trig. All right, so I'm going to look at what they've given us. Well, they've given us an angle measure. All right, that's our theta, that's our reference angle. Okay, so from that we can actually look at what sides we have. We have one side measure that we know, and if we look at that, it's across from our right angle. That would be our hypotenuse. So we have our h. Okay, and we have one side that we want to know. Okay, that's relevant to our problem, which is our question mark. And if we look at our reference angle, we are across from our reference angle, so that would be our opposite side. Okay, so we need to figure out which ratio uses opposite and hypotenuse. It would be your sine. If you think of your SOHCAHTOA, O and H go with your sine. Okay, so let's write down our trig ratio. Sine of theta equals opposite over hypotenuse. All right, that's the one we want to use. Okay, now we are going to create an equation with our trig ratio. Okay, so let's plug in what we know. If we have sine of theta, theta is our angle, so we know our angle. So sine of 50 degrees equals, and that is always opposite over hypotenuse. Don't think about where your x goes. Think about what your ratio tells you. Sine tells us opposite over hypotenuse, so it should always be opposite over hypotenuse. Opposite over hypotenuse. Our opposite happens to be x, so I'm going to put x on top. Over our hypotenuse, 6. Okay, so now we have an equation with one variable, which means we can solve it. I want to remind you that sine of 50 is just one number, right? We could type that into a calculator right now and get a decimal, but I don't want to write the decimal yet. So I'm going to wait till the end to type it in the calculator. We want to solve for our missing part, which is our x, which will be a side length. So I'm going to bring our equation back down. Sine of 50 degrees equals x over 6. So I'm not worried about this. All I'm worried about is what is with my x. Well, x is being divided by 6. I want to undo that division. Okay, well, to undo division, I need multiplication. So I'm going to multiply by 6. But whatever you do to one side, you have to do to the other side. So those 6's cancel, and I'm left with x equals 6 times sine of 50. Now remember, sine of 50 is one number. So it's just 6 times another number. But this is where we can use our calculator to get as exact as possible. Okay? I'm going to type in 6 times sine of 50. So you're going to go to your calculator. Okay? It'll look something like this. Your sine, cosine, and tangent are right here. Okay? So I'm going to type in 6. Right? Sine. Oh, I don't know how I got that cube root in there. Let's try that again. 6 times sine of 50. Okay, and close the parentheses. There's one thing I want to check. I want to check my mode, which is right here next to your second. I want to make sure my mode is in degrees. Right now I'm in radians. That's a different type of measure. I don't want to be in radians. So I'm going to go over to degrees, and I'm going to press enter. And now you can see degree is highlighted. So I'm going to second quit. And it'll take me back here, 6 times sine of 50 degrees. And if I press enter, I have my answer. I'm going to round to the hundredths, so that would be, this would round up to a 6, so 4.60. Okay, so x equals 4.60. Okay, if we look back at our triangle, we want to make sure it still makes sense. If our hypotenuse is 6, we know our legs need to be less than that because this is our longest side. So 4.6 seems to work for our triangle. Okay, let's try this process again. So let's look at example 1 here. We've got a right triangle with a degree measure of 39 on this angle. We have our x here that we want to find and our 7 here. So first we need to figure out which trig function do we use. Let's label our sides, okay? Across from our right angle is our hypotenuse. So there's our h. And then which side is your x? Is it your opposite or is it your adjacent? It is your adjacent. Our opposite would be across the triangle. I'm not worried about this side. I don't have a variable. I don't have a number. I'm worried about this. This is your adjacent. Okay, so which trig function uses adjacent and hypotenuse in the ratio? All right, if you check your SOHCAHTOA, I need to know which one uses A and H. Well, that is our middle one here, which is cosine. So cosine of theta equals adjacent over hypotenuse. Always write this out. Cosine of an angle equals a ratio. Okay, that's what it's going to look like. Trig angle equals fraction. So now fill in what we know. We know theta is 39. Cosine 39 degrees equals adjacent over hypotenuse. Our adjacent is x. X is not always in the numerator. Excuse me. You just put x wherever it fits in your equation. X was our adjacent, so it went in the numerator. 7 is our hypotenuse, so it goes to the denominator. Okay, we have our equation. Let's solve. X is being divided by 7, so I need to multiply by 7. Multiply by 7, multiply by 7. Those cancel, and I get x equals 7 times cosine of 39. All right, remember, cosine of 39 is a single number. I could type that in the calculator and get 1 decimal, but I'm going to wait till this point before I type it in. 7 times cosine 39. So go to your calculator, and we're going to do 7 times, remember your sine, cosine, tangent, cosine 39. We're already in degree mode, so we don't have to change it again. 5.44. Okay, so x equals 5.44. Check to make sure it makes sense. It's less than our hypotenuse, so I think we're okay. All right, and our last time here, we've got 46-degree angle. We have 8. We have x. Let's label our sides. So if this is our reference angle, if we go across the triangle, there's our opposite, which is our 8. If we go across from the right angle, there's our hypotenuse, which is our x. We're not worried about our adjacent side, so I'm not even going to mark it in my triangle. I don't want to confuse myself. Okay, which trig function uses opposite and hypotenuse? It's your sine. So let's make our equation. Sine of theta equals opposite over hypotenuse. Okay, I'm going to fill in what I know. I know theta is 46, so sine of 46. All right. Theta is always your angle, which is going to be inside your triangle. All right, and then it's opposite over hypotenuse. Always do opposite over hypotenuse when you're looking at sine. So opposite over hypotenuse, 8 over x. So 8 goes on top because it's the opposite side. X goes on the bottom because it's the hypotenuse. Okay? Now, how do I solve this one? Well, if I multiply here, like we did over here with the division, I'd be multiplying by x on both sides, and that's okay, all right? And that gets x out of the denominator, okay? But I'm not trying to solve for 8, so that gives me the equation x times sine of 46 equals 8. X is out of the denominator, but it's not solved for. all right? It's being multiplied by sine of 46. Remember, that's a number. So I just need to undo that. I need to divide by sine of 46. You keep it all together. So I'm going to divide by sine of 46, divide by sine of 46. So x equals, and I just typed that in my calculator, 8 divided by sine of 46. Not just 46. It's 8 divided by sine of 46. Remember, that's a unit. Sine of 46 is one thing. So don't just put 46 in the calculator. And here we go. We have 11.12. Oh, change colors. Let's check it. We are solving for our hypotenuse, so it should be larger than the side that we already had. And it is, so I think we are okay there. Okay, that's solving for missing side. Let's look at missing angle. So in this triangle, we know it's a right triangle, which is important. We have our missing angle, which will be our theta. Okay, it's our reference angle, the one we want to focus on. So we're going to see what sides we have. We have our 35 here and our 65 here. Guess what? The steps are the same. Just the solving looks a little bit different. Okay, first, determine which trig ratio to use. I'm going to label my sides. If this is my theta, okay, then I have my opposite side. Here's my hypotenuse, but I'm not worried about it because there's not a measure there. So this one would be my adjacent. So I need to know which trig function uses opposite and adjacent, and that's tangent. So tangent of theta equals opposite over adjacent. All right? That is the equation we're working with. Now we want to actually create the equation with our trig ratio using the numbers in our problem. So tangent of our angle. Well, we don't know our angle, so we're going to leave it theta. Tangent of theta equals opposite over adjacent. Opposite over adjacent. Opposite over adjacent. I'm going to plug it in exactly that way. Opposite 35 over adjacent 65. 35 on top, 65 on the bottom. Okay, now we're ready to solve, but the solving looks a little different. All right. Theta is not being multiplied by anything. It's not being added or subtracted or divided by anything. Okay. Tangent is not being multiplied to theta. It's being applied to theta. Okay. Kind of like a square root is applied to a number. Tangent of theta, okay, like an action has happened. We still need to undo that action, but we're going to use something new that you haven't learned before. All right. To undo a trig function, we use an inverse trig function. So what that looks like, so inverse trig. Okay, it's on the calculator. The calculator will do it for you, but this is what it looks like. It is tangent inverse. It has this little -1 at the top. In math, we use that to mean inverse. So we're doing tangent inverse of tangent of theta, and we're going to do it to the other side, tangent inverse of our fraction. Okay, so when you're using an inverse function for trig, you should be typing in a ratio, right? Well, tangent inverse and tangent cancel out. That's the goal. We want those to cancel out. That's why we did it. And we're left with just theta. Now this part, we just type into the calculator. Tangent inverse of 35 over 65. So I'm going to go into my calculator. My inverse buttons are actually right above my sine and cosine tangent buttons. I can get to them. They're in blue here, so that means I have to press second first. So if I want to do inverse tangent, I'm going to press second, and then I'm going to press tangent. So second tangent, and it gives me my tangent inverse. We use that to find an angle, okay? And then I'm going to type in my ratio, 35 divided by 65. And there we are, 28.3 degrees. And there you are. Okay, let's try another example. So here, we're looking for our angle again. So let's label our sides. If this is theta, if we go across from the right angle, there's our h. Our opposite would be over here. We're not worried about our opposite. We have our adjacent. Okay, so which trig function uses adjacent and hypotenuse? That would be your cosine if you think of your SOHCAHTOA. So cosine of theta equals adjacent over hypotenuse. All right, so let's fill in what we know. Cosine, our angle is unknown, so we leave it theta, equals adjacent over hypotenuse. Adjacent over hypotenuse, 26 over 45. Okay, I want to find the angle, which means I need to undo the cosine. And we use the cosine inverse. Excuse me. So we're going to do cosine inverse of our cosine of theta and cosine inverse of our 26 over 45. We're just going to do cosine inverse to both sides. Okay, just a reminder that it cancels over here and we're left with just theta. And then we're going to type this part into the calculator. Cosine inverse of 26 over 45. So go to our calculator. Remember to get to inverse, I press second, then our cosine. And that will give our cosine inverse. And it was 26 over 45, I think. 54.7 degrees. Sorry, 54.7 degrees. Okay, and you can always check your triangle to make sure that actually makes sense. Okay, last one of this type. We'll do this real quick. We have our missing angle, so that's our theta. Let's label our sides. We have our opposite. We have our hypotenuse. So which trig function uses opposite and hypotenuse? That is your sine. So sine of theta equals opposite over hypotenuse. Let's plug in what we know. Theta is missing, so leave theta there. Opposite over hypotenuse. Opposite over hypotenuse. 16 over 19. Okay, I want to solve for theta, so I mean to cancel out sine. That would be sine inverse. So I'm going to do sine inverse of this side. And I'm going to do sine inverse of this side. Okay, sines cancel over here, so I'm left with just theta. And theta is going to equal the sine inverse of 16 over 19. So let's plug that into the calculator and see what we get. 16 over 19. So, last reminder, if I want sine inverse, I do second first and then get my sine inverse. Second sine, and it was 16 divided by 19. And that gives us 57 point, this rounds up to 4. Theta equals 57.4 degrees. All right. Now the last thing I want to talk about on this video is the relationship that sine and cosine have. They actually have a special relationship. Okay? When you're looking at a right triangle, angle A and angle B are what we call complementary, which means they add to 90. So basically we're saying A plus B equals 90 degrees. All right? And the reason is because we already have 90 degrees in our triangle. All right? So that means we only have 90 degrees left to add up to 180. Okay? So A and B have to add up to 90 degrees. So let's look at sine of A versus cosine of B. So the sine of A would be opposite over hypotenuse. So if here's A, my opposite would be A, the hypotenuse is C. So sine of A is A over C. Cosine of B would be adjacent over hypotenuse. So the adjacent to B over the hypotenuse C. So if you look at this, what do you notice? Sine of A is A over C. Cosine of B is A over C. They're the same. And that's because the sides that we're using are the same. The opposite of A is the same thing as the adjacent of B. Okay? Let's try it again. What if we switch it around? The sine of B, so let's do the opposite, which would be B, and the hypotenuse, which is c. So that would be b over c. And the cosine of a, so cosine of a would be adjacent in hypotenuse, so the adjacent to a would be b, and the hypotenuse c. So we see the same thing happen here, okay? And this is actually a pattern that we can use to our advantage. If our two angles add up to 90 degrees, then we can see that the sine of one is equal to the cosine of the other. All right, so let me write that in words for you. If a plus b equals 90 degrees, then the sine of a equals the cosine of b. And we can actually reverse that, and the reverse is true. If the sine of a equals the cosine of b, then we know that a and b must have been 90 degrees. It's a pattern that always holds true. So I just want to do a couple of these. Sine of 30 equals the cosine of what? Well, it just says that if sine and cosine are equal, then your two angles have to add to 90 degrees. So 30 plus what equals 90 degrees? 60, and that's your answer. These are complementary angles, so their sine and cosine are equal. Sine of 30 equals cosine of 60. Let's try another one. If it's the sine of 75 equals the cosine of what? Well, what adds to 90? 75 plus what equals 90? If you're not sure, you can always just subtract 75, and you would get 15. Okay? And you can also reverse it. Cosine can come first. Cosine of 12 equals the sine of what? If cosine and sine are equal, then your two angles have to add to 90 degrees. So 12 plus what equals 90 degrees? You could subtract 12 to help you solve it, and that would be 78. Okay, so I'm going to skip over 4. If you look at 5, we can actually take it one step further, okay? We can actually have an equation for our angles and use this to our advantage to solve for a missing piece. So sine of theta plus 6, which is your one angle, equals cosine of theta plus 4, your other angle. If sine equals cosine, then your two angles add to 90. So I know that this plus this equals 90. So let's actually write that out. I know that theta plus 6 plus theta plus 4 equals 90. Well, I have an equation with a variable. Theta is just a variable like x. You can think of an x, you can think of an x. So I can combine like terms. Theta plus theta is 2 theta. 6 plus 4 is 10. So just like terms here. All right. Okay, and that's going to be equal to 90. Now I'm just going to solve it like any other equation. I need to get theta by itself, so I need to subtract my 10, and I would get 2 theta equals 80. So what does theta equal? Divide by 2, and you get theta equals 40. So knowing this relationship that when sine equals cosine, the two angles add to 90 can help us solve more problems like these.